Starting with the name of the most merciful and most gracious Allah. Thank you so much, Moise, for the warm introduction. And I would like to extend my welcome to all the faculty members, to the graduates, and especially the organizing committee, who, like, the guys are working really hard to make this event a success so that we can resonate the name of Pakistan across the world. And especially last night, I was actually looking into the video of Sir Yasir, and sir, I really appreciate the work you are like doing to maintain this ecosystem. And so today's topic is very simple and relevant. We have Python, and my basic goal is to give you a brief introduction and idea that how we can build smart applications and smart solutions with the help of WebRTC, which is kind of, you can say, a combination of word web and real-time communications, such that we can improve our daily communications and interactions like more intelligently and more efficiently. So before dive into the idea of the before moving into the topic, let me introduce myself, and I just want to pay a tribute to my mom, who has been a continuous support in my journey throughout this year. So I started my career in 2018, and I vividly remember that in the initial days when I started my career, I built a very small prototype based on Python, and you can say using the help of UDP and TCP. And this was the basic idea that how I can relay audio packets of 1v1 audio video call, and then that audio video call can be, you can say, pre-processed using a middle service which was built on Python. It was a simple program which was built, and it was around like 50 to 60 lines. And the basic concept was like we were building an idea that we are going to replace a conference phone inside the meeting room. Let's say we have two meeting rooms, and there is a conference phone placed in both of the rooms. So this was an engineering idea that we are no longer required those conference phones, and we will use our own smartphones. We will place on the table. Their audio will be sent to some middle service where that audio will be mixed, and then that audio will be sent to the other room. And on the other room, if there are n number of like people sitting inside the room, maybe 10, 12, or 100 of users, so the audio which is being mixed with the help of a very simple program of Python to the other room in a more synchronized way, such that it will create an acoustic impact in the room, that a single audio is being played on all the devices. So this was the basic concept. And starting from the basic, you can say, a programmer, to securing a patent in the USA, and then moving forward, I was last year I was honored a title of Mr. WebRTC in a community meeting held by IEEE and Ant Media. Ant Media basically an international brand for providing audio video conferencing and streaming solutions. So in that meeting, they somewhat, because of my research work and my development, they called me Mr. WebRTC, and that was, and you can say, an extreme honor, because there were more than 200 people in the meeting from all across the world, and most of the community members from Google and Microsoft. My current role is in Younite is as you can say head of backend and infrastructure, and I'm also working as a founding member in the team. Apart from that, from last 3 years, I'm serving as a consultant as an AR VR consultant in NHS England. So I just want to spend a little bit time to pay tribute to my mom. Uh, Throughout my journey, she was rock solid. She was my guiding star, and uh, she is the only reason I'm standing in front of you guys. She left me in last December 2022, and her passing was not profound. And I was, at the end, I was trying my best that I can. So I think I want to stop this. Was so sorry for that. Actually, I was talking about my mom. As I mentioned that she left me last year, and I exactly remember that how she has been through a lot of, you can say, situations, and through the events to make me a very talented and very respectful, you can say, technical person in the community. And I'm sharing this with you all, with all of you guys, just not to honor my mom. Uh, uh, just The reason is to inspire all of you guys that every one of us have some sort of people who made the difference, who work really hard, such that to made who we are today in today's world. So I was very sure about that when I going to discuss about my mom, there might be a situation like that. So apologies for that. Today's agenda is very simple. That we have WebRTC and how we can use Python to, you can say, incorporate AI algorithms in real-time communications, especially to enhance the video quality, to the audio quality, and a lot of other, you can say, aspects during the real-time communications. As I was talking to Osama, in the meantime, he mentioned that after my session, there is a Zoom call, which is a real-time communication, you can say, example. And so if I a little bit explain about the Python was initially the primary building block to solve the complex problem. I personally use Python to build fast prototyping, and to, you can say, to perform quick MVPs, to show demos to, you can say, multiple clients. I actually compiled a couple of three different images from Stack Overflow from 2021 to 2023 for you guys, so that I can explain the consistency of Python throughout all the 3 years. No doubt, Stack Overflow is doing a survey at the end of each year, and in that survey, there are three main key points on which Python is Stack Overflow is explaining that what are the programming languages, what are their role in real world, and how many number of, you can say, jobs have been offered for that particular programming language. So if we see in 2021, you can say that you can see that Python is at Python is at third rank, and even you can scan the QR code to visit this survey conducted by Stack Overflow. And now, if we move further to 2022. Here's 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 a difference. Most of the people like to, you can say, learn code using the help of like Python. So Python again at the end maintain its position among the most popular languages. Apart from that, in 2023, again its consistency and retention was same across all of the scripting languages in the world. So it's just like we can say that its consistency is somewhat like Babar Azam, who is the most consistent player in the world right now. So I will here explain the basics of WebRTC. Normally, we say that WebRTC is a you can say set of APIs to build cross-platform real-time applications. So I think the birth of WebRTC was around like 1999. Most of the organizations from the IP providers, they were initially taught that we could bring audio video, you can say calling functionality in the browsers. So in 2006, Google acquired the source code of WebRTC and name it WebRTC. So apart from the web browsers, I think WebRTC has been evolved throughout all the years, and now we can even build the cross-platform applications for mobile devices, even for the desktop applications. The basic, you can say, a good feature of the WebRTC is that it's a peer-to-peer communication. So it's not like the WebSockets who have a server-client architecture. If you want to communicate with me, you just need my initial details like who am I, and you also share that who are you, and then we can just start transmitting data here and there. And data can be like audio, video, and any kind of like file sharing. So the basic definition, if we put about the WebRTC, is it's a peer-to-peer. It's high quality and you can say real-time media transmission. And apart from that, it provides strong APIs to build, you can say, cross-platform applications. This is a normal flow of a call between two participants. So if peer A wants a communication with peer 2, before moving to this step, the data stream step, we need two different, you can say, components which are in association with the WebRTC to make a one-on-one call possible. Signaling server is a kind of, you can say, middleman, which is sharing the unique information between the two participants, such as the network information and the media information, that if I'm going to share my audio or video, or simply it's just you can say some sort of any data sharing like files or images. So signaling server is basically the main thing which is deciding that peer A and like who are the peer A and what are the, you can say, references of peer B. So after the initial information sharing, data is being transmitted between the two parties in a more P2P way. There is an additional aspect involved which we call somewhat media servers, but media server came into the topic when we talk about large like conferences or webinars, just like Twitter Spaces. So if we keep the reference of this image in and move to the next slide, here we can see that Python is serving as a signaling server between two JavaScript web-based clients who wants to make a one-to-one audio video communication. So it's more like the brain that will that will decide that who person wants to communicate with whom. And apart from that, if we see that Python is basically if Python is acting as a signaling server to maintain a call, So if there is a network shift or any other, you can say, user is disabling his camera or any stuff like that, then Python can be utilized to make the real-time interactions between the two users accept the data, because data is transmitted in a peer-to-peer way. These are the two libraries which are built on the top of WebRTC. One of that is asynchronous input-output for real-time communications, and the second one is PyWebRTC. These are the basically libraries through which we can build a WebRTC-based application. In this, you can say, aspect, Python is not acting as a WebRTC based endpoint. Python is acting as a middleman, which can initiate the basic handshake between the two participants. So if we decide to go for the integration of Python and WebRTC, we can use like Python on the either side. Either we can use for the video conferencing or file sharing or for the screen sharing purposes. The main goal is, if we are doing a peer-to-peer communication, we can build AI models and then we can directly utilize inside the mobile applications. Recently, we have incorporated a recurrent neural network based noise suppressor inside the mobile SDK of WebRTC, where we are basically suppressing the background noise during the real-time audio calls. So what's happening is that model is more efficient enough, even if there is a background music going on or if someone is sneezing, it completely erupts the background noise from the audio to make it more clear. Apart from that, as I mentioned, that we can use Python to build the fast prototypes. If we want to show some kind of an MVP to the customers, then we can use Python-based libraries to build a kind of web applications with the help of Flask or Django frameworks, using the you can say available modules built on top of WebRTC. So further, we will only discuss three different aspects of, you can say, future trends. AI is all over the place right now. So most of the organizations who are building their smart applications, even multiplayer games or in AR VR streaming, they are utilizing AI for the you can say communication apps. So let's just assume that we have a middle person or middle service through which we are communicating to the other participants. And if there are hundreds of users, then we need a service called media server. And most of the media servers in the market, they are utilizing Python more efficiently, including they are doing some sort of processing on the media server side. So all the users are sending real-time audio and video data to the media servers, and then media servers are basically, if the data is encrypted, data is going to decrypted with the same handshake maintained by the WebRTC to the media server, and then at the end we have video. We can enhance the video, we can mix the audio streams, and I exactly remember I used the basic program of Python to mix around let's say if 10 users are sitting in a single meeting room and the other room is contained with around like 7 to 10 members, then their audio was mixed with the help of NumPy. And later on, when we shifted into the C++, it was like we are building something which is similar to like NumPy, and we are getting away from our main and exact goal. So if we introduce Python into the communication apps, there is a bigger room for us to, in terms of audio, we can provide the clear audio transmissions. We can even enhance the video images with the help of, you guys know that a very efficient computer vision based libraries are already available inside in Python. Apart from that, if we are again if we want a sentiment analysis of calls, so we can even transcribe the real-time audio calls, and then we can somewhat reduce the language barriers between the participants. So I think this is a roadmap how we can integrate AI with the WebRTC. I think I can just evaluate all of these steps into the four things. First, we have to decide that what AI is best for our audio video calling applications or multiplayer gaming. Like if I talk about the multiplayer gaming, AI can decide that what is the best routing for a participant, such that the participants may not consider any kind of lag due to the network fluctuations or the processing power of the cell phone. Apart from that, uh, if we choose that AI model, then we have to incorporate the AI model, and we have to uh, look into the model in a way that it will definitely reduce the latency of a given communication system. In during the audio calls or video calls, latency is the biggest problem in the world right now. So if we are incorporating any kind of AI algorithm inside the communication app, then we have to make sure that this AI model is not going to introduce any kind of additional latency to the existing flow of audio and video. So here are some useful use cases which we can use with the WebRTC and AI. First of all, if we are improving some sort of call centers, then we can reduce wait times and even enhance the service quality. Speech recognition and translation is, you can say, nowadays very common. In NHS England, we are basically producing a summary at the end of a session between doctor and a patient. So during their session, we are continuously recording that session and getting the live transcription. At the end of the session, we are generating a summary, which is very common nowadays. Adaptive bitrate streaming is a, you can say, main factor. Normally you guys, while talking on WhatsApp or even while like having conversation on Meet or Teams, you guys, when your internet is like, if you are away from the access point or your internet is not good, you guys may consider a lag or a stuttering sound. So adaptive bitrate streaming is a kind of, you can say, adaptive algorithm which is being used inside the WebRTC to maintain the audio quality or readjust the audio quality based on the internet speed. Apart from that, voice and video analytics. If we have a video conferencing application, then we have more structured information on the backend side. And if we have incorporated any kind of media server, then I think there is a possibility that we can consume a lot of real-time and structured information. These are some sort of, you can say, useful informations. We can even reduce the background noise cancellation. Sometimes if you call to the customer services of any of your like mobile providers, you guys may have listened the background noise of other agents while talking to your representative. So we can use AI algorithms, the sort of we have used in our WebRTC based SDKs to remove the background noise. Facial recognition and tracking has been, you can say, a long journey, and I think most of the universities fellows are doing some sort of, you can say, semester-based project to recognize the face and tracking. But in real time communications, this is some sort of a different. If we have a static video and if we have a real time audio video calling applications, so to build a real time algorithm based on Python and AI is a kind of, you can say, a different approach. So there are some other video coding algorithms to improve the video quality. These are some sort of, you can say, compression algorithms to provide you the more bandwidth over the internet. Virtual backgrounds and AR filters are very common nowadays, and content-aware streaming. Most of the, you can say, developers and gamers, especially gamers, are doing some sort of streaming based on these tools. So at the end, I will urge you guys to look into the WebRTC, and if you guys find a space to collaborate to the communities, that would be really great. And I think if you guys have any questions, so I can. Thank you.
क्वेश्चन मेरा ये है कि आपने और रियल टाइम आप कम्युनिकेशन की बात करें, गेमिंग वर्ल्ड में इसका कोई है कंट्रीब्यूशन, और आपने ये बोला कि एआई जो है और ऑप्टिमाइजेशन कम्युनिकेशन पार्ट्स की बात की हो, तो जब आप गेमिंग वर्ल्ड में काम कर रहे हैं तो वहाँ पे एआई कहाँ पे प्लेस हो रहा है?
So basic idea in the multiplayer gaming is, you can say, the latency. There's a company in Pakistan called Minerbugs, and they have actually initiated a program to build their own multiplayer games. So the basic issue they are facing is the latency. So normal, you can say, multiplayer servers which are being used in the world are Photon servers. So what's happening here is they are almost getting a latency of more than 100 milliseconds. So while using the WebRTC, I have personally observed, and you can say created some practical examples of real-time games, such that we have observed around 20 to 30 millisecond of peer-to-peer latency. So WebRTC also has a capability that we can even talk with 8 members in real time without the need of any kind of media server or any other middle service through which media is being relayed. So when we talk about, you can say, multiplayer gaming and the concept of WebRTC, then the basic thing is the latency. And definitely, I'm also working on basically SDK building for a multiplayer game, and I hope so within next or 2 months it will be finished, and maybe by this year we have a full-fledged game based on, you can say, WebRTC and a multiplayer SDK.
Thank you. और एक इसके साथ ये ऐड करना चाहूँगा कि अगर हम लोकलाइज्ड सर्वर के ऊपर इसको यूज करें, अब लेटेंसी में फर्क पड़ेगा, और अगर हम लोकली सीडीएन बेस्ड जो होते हैं उसके ऊपर करें, क्योंकि यहाँ पे नया टेलर जैसे लोग भी ऑप्टिमाइज सर्वर्स की दे रहे हैं, तो आप क्या सजेस्ट करते हैं?
Basically, for WebRTC, there is no need of any servers. WebRTC is directly P2P communication. If you guys are like considering to make a multiplayer game for around like 25 participants, and they can even talk to each other, they can share real time, you can say, their health and even some sort of other information. So I think there is a bigger room that we can establish a mesh network between the participants. Like if you, me, and Sir Yasser wants to talk, then there will be a direct P2P communication. Even we even not need any kind of additional middle service to relay any kind of media, which includes audio, even video, even random or arbitrary data. So I think there is a bigger room to improve the latency because it's not using any kind of servers.
Thank you so much.